Assalamualaikum and hello everyone. So today we are going to discuss about solving problems for energy and photon powers in quantum physics. So today we are going to discuss about 4 questions and how to solve it. So let's go. So this is question 1. It says, what is the energy of a photon of frequency 1024 Hz? Okay, so what we have here, we need to find the energy. We are given the frequency. So the formula is energy is equal to Planck constant times by frequency. We can search the energy. So the Planck constant is 6.63 times 10 exponent of negative 34. This is a Planck constant and the frequency is 1024 Hz. So this is a simple equation and we solve it using the calculator. So as we can see, we get the energy is 6.63 exponent of negative 10. So this is the answer for question number 1. Moving on to question number 2, it says, what is the energy of a photon with wavelength of 10 nanometer? So as we can see, we need to find the energy, but we are given the wavelength, which is lambda. So lambda is equal to 10 times 10 negative 9, since it is nanometer. So this is in meter. If we have the wavelength, the formula will be exchanged to E is equal to HF. This is the original formula, but we also know that frequency is equal to C over lambda. So we have lambda, H is Planck constant, and C is speed of light. So we can conclude that 6.63 times 10 exponent of negative 34. So the light is 3.0 exponent 8 over lambda. So we just substitute here in here, 10 exponent of negative 9. So we grab our calculator. So this is the answer. As we can say that the energy of photon is 1.989 exponent of negative 17 joule. So this is the answer of energy for question number 2. Next, we continue to question number 3, which is, it says, what is the number of photons emitted per second by an UV light lamp with wavelength of lambda is equal to 4.0 exponent of negative 7 meter of 50 watt. Okay, so we know that this is power, and the number of photons, we assume this is n and this is lambda. So as you can see, this is the original formula of the power, which is power is equal to NHF equal to NHC over lambda. Since we have lambda here, so we use the second formula, which is P is equal to NHC over lambda. So we need to find the N. We want to find the N. So we bring all the other function to the left side. So we have N is equal to P lambda, bring HC to the other side, so HC. So this is the formula that we are going to use. So the N is equal to power is 50 and the lambda is 4.0 exponent of negative 7. The Planck constant is 6.63 exponent of negative 34, and the speed of light is 3.0 exponent 8. So we grab the calculator and transfer all the information. So we get the answer for the number of photon is 1.01 exponent of 20 per second. So this is the answer for question number 3. Moving on to the last question, it says suppose 10% of the output power of 100 watt bulb used to emitted 2.92 exponent of 19 photons per second. What is the average wavelength of the light in nanometer? So we have the power, we have the number of photon. We need to find lambda. First step, what we are going to do is we need to find what is the 10% of the 100. So the real power is 10% times by 100 of watt. So as we can see, this is only 10 watt. So this is the real power that we are going to use in this formula. So we need to find the lambda. We have to bring lambda here and we have to put the P down. So the real formula will be lambda is equal to NHC over by the power. So the number of photon is 2.92 exponent of 19. The Planck constant is 6.63 exponent of negative 34, and the speed of light is 3 exponent of 8. And the power, this is the new power, so divided by 10. So as we can see here, the answer will be 5.81 exponent of negative 7. But in the question, we need to find it in nanometer. So what we are going to do is we move this point here 2 to the right, and we have to minus by 2. So the real answer would be 581 exponent of negative 9, which is equal to 581 nanometer. So this is the answer for the last question. So that is all for today. I hope you enjoy and I hope it will help you a lot. Thank you for watching.